Good morning, and welcome to Test Prep Time Live with Method Test Prep. My name is Oliver Luisi. I'm the Director of Tutoring here at Method. And today I wanted to look at a specific topic that comes up on the ACT primarily, and this is science passages. This is a pretty unique section of the test. The science section focuses on different topics within science, but is much more similar to the reading section in that most of the information you need on the science is given to you in the passages. So we're going to look today at some typical aspects of science passages, some really important strategies and insights to know heading into the science section, and ways to decipher or simplify some of the information that is shared on each passage. Some of this will also apply to science reading passages on the SAT. All right, let's take a look at a few important key ideas before we get started with some sample questions. Okay, now on the ACT, the science is the last section of the test. It comes after your reading section. And like I mentioned, it's very similar to the reading section in that in the reading section, you get presented with passages on a variety of topics, and you have to use the information in front of you to answer the questions. You don't have to have already read that novel or to know a lot about literature to answer the questions. You would just reference the information in front of you. In a very similar way, the science is presenting you with studies or experiments, and almost all the information you need is in front of you. It's a matter of reading and finding information efficiently and quickly. Now, the passages on the science are called passages, but they're really, in essence, just experiments or studies. A quick note about experiments versus studies. It's not hugely important that you make a differentiation each time you're on a passage, whether it's an experiment or study. I just want to outline a couple of ideas about experiments or studies. A study, and the main difference is that a study is just making observations or collecting data about something that's already naturally occurring. So you didn't make anything happen, you're just sort of measuring something that's already out there, or maybe recording the sunrise every day, or looking at some other scientist studies and compiling some of their data. So it's already out there, it's already happening, and you're just making recordings or observations. That's a study. But in an experiment, what happens is you introduce something new. So you introduce some sort of cause, and you measure the effect of that. And that is usually known as a variable of some kind. And you're measuring the effect of your variable, and you can change up your variable and try different things. And you're always going to compare it back to a group or a segment that you don't do anything to, and that's known as the control group. So here's a simple example. If we were doing a study, I would maybe go out to my front lawn and scoop up some soil and test the pH value of my soil. I didn't necessarily do anything to it. I'm just seeing what's naturally there and going to see what my pH is. Is it 7? Is it 5? Is it 12? Measuring my pH. What would be different in an experiment is, in an experiment, I would go out to my front lawn and I would pour a bunch of chemicals on it, and then I would test the pH after the chemicals were applied, and I would compare that front yard maybe to my backyard where I didn't put any chemicals, and that would be the control group. So that's a difference in an experiment. You have a variable group where you're testing the effect of something, and then you have a control group where you're not doing anything to, and you're seeing the difference in measuring that effect or that difference. Okay. When you get to the science section of the ACT, you're going to get about 6 passages. They're all very similar. And one of the key things is going to be that most or a good amount of your information is going to be within charts or figures or tables or graphs. So we do have to get comfortable and familiar with identifying the information in tables or charts or any kind of data source, any kind of figure. And so those will be some critical places to look. The next thing I want to point out is when you get to a graph or chart, you do want to make sure you note all the different pieces, and we'll look at that in a moment: the title, the labels, the units, the axes, and any trends. Here's the next important tip. This is a little unique to the science section, but in this ACT Science, my recommendation is to go right to those questions and just start them. Now, you might not have read anything about the passage yet or learned too much about the experiment. That's fine. You're just going to do the questions as you go, and you're going to go to the places you think where the information is. And so most of the early questions in the passage, you'll be able to get just by going to a certain table or chart. You don't have to learn every last detail or everything about the passage. If you go to a table or chart and don't find all the info you need, that's fine. Then you're going to go to skim the text or the paragraphs and see if you can find keywords or information you need there. You want to approach the science in the sense of focus on answering the questions and just glimpsing out and getting the information you need as you need it. Don't try and learn everything up front and then do the questions. You won't have enough time. Within any passage, the question difficulty is increasing slightly. So let's say you had 6 questions, but 1, 2, and 3 might be a little easier. 4, 5, and 6 will get a little more challenging. And they may introduce hypotheticals, which we'll look at in a moment, where they're introducing a question that gives you new information or a new situation that wasn't in the original experiment. They might redo the same experiment and say, what if we did this on Mars instead of Earth? How would it be different? Okay. These are a couple just quick snapshot of different data sources you might see: table, a chart, a bar graph, pie chart maybe, and figures diagramming an experiment with different equipment. All of these things can be different data sources you'll see on the science section. When you get to any one graph or table, take a few moments and orient yourself. Just 20, 30 seconds, however long you need, to just note some critical things. First, what's the title? Don't skip that. The title often gives me a lot of information about what this graph or table will show me, right? So here it says voltage changing over time. So I know something about volts and something about time and how it's changing. Also, if there's a legend, note the legend. Here we have 3 different lines, so we have to differentiate what each one means: dotted, dashed, or solid line. Next most important is definitely the axes, right? The X and Y axis. Pay attention if there's 2 Y axes, for instance, or something unusual in the axes you're not used to seeing, but mostly pay attention to what they're measuring. Voltage here is on the Y axis, and on the X axis is time in seconds or milliseconds. Pay attention to the units. And how are things changing? Is there any trend? Is it increasing or decreasing or a little bit of both? Those will all be key things to pick up on every graph or table or chart. Okay, let's take a look at a typical science passage here. I want to point out a few key things very quickly before we look at a few questions. Now, when I get to the science passage, I really just want to focus on going to those questions and doing the questions. That's where I'm going to start. But I want to point out a few things here quickly, just so you know when you go back to the passage to find answers, where to look for things. First, there's going to be some overview or introduction where they're going to talk about the basic outline of what's happening. And here they even give us a chemical formula, give us a little background. They give us a figure or a diagram showing us how the experiment is set up. Notice here in each of the trials, they talk about 3 steps. These are the 3 steps of setup, right? So they're basically showing us what are the things or the steps they took to conduct this experiment. Now, it looks like there were a couple of different experiments here because I see experiment 1 and an experiment 2. Okay, great. So I can see that the results of experiment 1 are shown in this figure and the results of experiment 2 are shown in this figure. Okay. Now, when I get to the passage, the first place I want to start is just on the questions. I'll come back to exactly the place I need for that information. As I go further, and if there's certain pieces of information I need that I don't find in the charts or graphs, then and only then will I start to peek into the paragraphs and check those out for keywords or information that I need for the question. All right, a couple of key things as we go through. First, I'm going to start with question 14, and I'm going to clue into every part of the question that leads me to the information I need. You can read the question in its entirety as a whole, but then you do want to go back and sort of take it in bite-sized pieces. Don't try to understand everything at once. You want to look at little small parts of the question to pick up on the specific info. Okay, consider the volume of gas collected in the trial and experiment 2 for Ni at 30 degrees Celsius. The same appropriate volume of gas was collected in the trial and experiment 1 for what mass of Ni? Now, don't be discouraged the first time you come to a question. It sort of sounds like a foreign language. Maybe you don't understand much of what's going on yet. That's fine. You're going to break it into pieces and go find the information you need. So here we need to look at a volume of gas collected in the trial for experiment 2 for Ni at 30 degrees. Okay, volume of gas, experiment 2. So I'm going to look at this figure. The volume of gas for Ni. So I'm focused on here, the line with the little boxes. That's this middle line, Ni. And I want the volume of gas collected at 30 degrees Celsius. So take a few moments, orient yourself on this graph. I've got volume of gas on the y-axis. I've got temperature in Celsius degrees on the x-axis. And I've got 3 different, it looks like, elements: iron, nickel, zinc, or just call them Fe, Ni, and Zn. And you can see how they are changing as the temperature increases. It seems like the volume of gas increases. So here's your next important tip. The science section is full of relationships, and anytime you can establish a set relationship, mark it down with big arrows. So for this experiment, every time the volume of gas increases, the temperature also increases. So I'm just using some abbreviations and some simple arrows here to highlight the direct relationship. As one aspect increases, both aspects increase. So it's a direct relationship. Let's go back to the question. Okay, the same approximate volume of gas. So let's go to our figure and we note at 30 degrees, if I look at nickel, the volume of gas at 30 degrees is right here. That was the recording. Now I want to follow that over to my y-axis as close as I can. You can use a straight edge if you need to. And it probably looks around maybe 127 or so. It doesn't have to be exact. But now I'm looking for the same volume of gas that was collected in experiment 1 for Ni, and they're asking for what mass do I have for the same volume of gas. If I go to figure 1, I see volume of gas on the y-axis again, and I'm looking for nickel once again, which is the middle line with the squares. And I'll note, what volume of gas do I need? We found around 127. So I'm going to go here, 127. That would be right around here. And if I follow that over to my nickel line, there's the reading. That gets me 127 milliliters of gas. And that was recorded what? At a mass of 0.3 grams. And therefore my correct answer is choice H. So you can see here I had to relate 2 figures, figure 1 and 2. I had to find information in this first one and then relate it back to this figure as well. Okay, let's take a look at this next question. How many temperatures were tested in experiment 1 and how many temperatures were tested in experiment 2? Let's go to experiment 1 first. How many different temperatures? Well, in my figure I can quickly see there is no temperatures. Or there are no temperatures. It's only mass and volume of gas. Okay, where do they say anything about temperature? Aha, it's in the description just above. It says that each of the selected masses was tested at 30 degrees Celsius. Since I don't see any other temperatures here, I have to assume this was the same temperature used in each of my measurements. Therefore, experiment 1 used only one temperature, 30 degrees Celsius. It's got to be choice A or B. I can now get rid of C and D. Let's go over to experiment 2. In experiment 2, we have similar graphs, similar figure, volume of gas on the y-axis, but on the x-axis now, not mass, but we have temperature. Now, be careful here. Although they show me temperatures ranging all the way from 10 degrees Celsius to 50 degrees Celsius, the actual plot points or data points, as represented by these little markings, either circles or triangles, these are actually the measurements that were made. And so they only were made at 5 different temperatures. And you can see that represented by the data points here. So in experiment 2, there were 5 temperatures. So I've got to choose from B or D. I've already crossed off C and D based on my first experiment. So the correct answer here is choice B. Experiment 1 had 1, and then experiment 2 had 5. So make sure to pay attention to the values and the axes and to know what information is given in each graph or figure. In number 16, we're asked, which of the following statements describes a difference between experiment 1 and 2? This is another important concept on the science. What is changing on each trial or each experiment? What's different? That's what you want to pay attention to. And this question is asking us specifically, how does experiment 1 differ from 2? A good way to approach these questions are to go through the answer choices and check them out. So starting with F. In experiment 1, only Fe was tested, but in experiment 2, Fe, Ni, and Zn were tested. I can quickly see in experiment 1, all the elements were tested, and here, all the same ones were tested. That's not true. G. In experiment 1, Fe, Ni, and Zn were tested, but in experiment 2, only Fe was tested. Notice how this answer choice was just a reverse of the last one? Still wrong. They tested all the elements in both experiments. So be careful for flipping answers on the science. It's the same wrong answers, just flipped over. You notice they do a similar flip in H and J, but let's be careful and look closely at the answers. In H, in experiment 1, the same mass value was tested for each metal, but in experiment 2, multiple masses were tested. In experiment 1, not the same mass, because look, the mass is changing here in figure 1. Different masses across the graph. That's not true. And choice J, experiment 1, multiple mass values of each metal were tested. I can see multiple values here and multiple values tested here as well on each line. And in experiment 2, the same mass was tested. And here in experiment 2, I see that 0.3 grams was used, and nowhere else in the figure do they talk about mass. So the same mass was used for all of them in this experiment. And therefore, J is my correct answer. Use the information in the answer choices to help guide you as to what you need to find. The question and the answer choice will be full of details that will point you to the right place to look for the information in the figures or tables or even in the paragraph. Now in 17, it asks a very common question, which is, what variables remain constant? So we talked about a control group where no variables are used, and the variables are the things that are changing. You're going to test maybe temperature or test different masses. We want to know what variables remained constant. So these are the things which did not change within your experiment. If we look at experiment 1, the elements were all tested at 30 degrees. That seems to have been the constant, and that's not changing because the mass is changing as I go here, and the volume is also changing of gas. But the temperature in experiment 1 is constant. In experiment 2, it looks like the mass is held constant, 0.3 grams, and then it's the temperature that changes. So in neither case were the temperature and the mass the same. Those were the variables, so those are not the answer. In this one, mass changed. In this one, temperature changed. So I can cross those off. And what else didn't remain constant? Well, look, the volume of gas in both experiments is changing. So that's also not the same constant in both. I don't see much here about atmospheric pressure. So that's probably a safe bet that that's the one that didn't change because they don't show any values changing. If I wanted to really be certain of my answer, I could go back into the passage. And if you look carefully and you key in on the keyword atmospheric pressure, in the trial setup, when you see the steps of the experiment, at the very bottom, they actually say, oh, the atmospheric pressure was 758 throughout all 3 steps. So that was held constant. Okay, last but not least, let's look at question 18, because this is another critical and key idea in the science section. 1 or 2 of your questions in each passage will usually introduce a hypothetical. Look for words like if or suppose. What they're doing here is saying, what if we looked at one thing that we didn't talk about yet? Or what if we changed one thing? Usually what they're asking about is maybe a data point that is within the data you have. For instance, in figure 2, we see a bunch of measurements at different temperatures. What if they asked about a measurement at temperature 25 for zinc? I don't have one there, but I could use a little inference and make a guesstimate as to what the volume of gas would be there, even though I only have readings at 20 and 30. Okay, in this specific question, they're saying, what if there had been a measurement at a temperature of 5 degrees Celsius in experiment 2? Would the volume of gas collected for zinc be more likely greater than 107 or less than 107? So at 5 degrees, that's the temperature I want to look at in experiment 2. But you'll notice it stops at 10. It doesn't go any lower than that. That's fine. What they're asking me to do is not look within my data like I did for the example I just stated. We're focusing on zinc, but I want to take zinc's line and imagine it going even lower, right? Down to 5, if it went to a measure of 5. Now, they're not asking for the exact value here. They're just asking whether you think it's less than or greater than 107. It looks like the reading at 10 degrees was about 107. If this line continues the same trend, then a reading at 5 degrees would have to be less than 107. So I can cross off F and G. It's not greater than. It's going to be less than. Now let's look closely at H and J. H, it's less because for any given metal, the volume of gas decreased as the temperature decreased. The volume of gas goes down as the temperature goes down. Yes, all these lines look to be a direct relationship. And therefore, I now know that H is my answer. J is wrong because it says the volume gas decreased while the temperature increased. Nope. Remember, I already established that with my arrows that it has a direct relationship. So these can be tricky because they're introducing a hypothetical or a new information, but don't be thrown off by it. You still have the info you need. You just have to either place it within the data you have or pull your line or your trend out beyond the edge of the data. And you can see what would happen at extreme temperatures at 0 degrees or maybe 100 degrees. You're making a little bit of an inference based on the information you have. Okay. All right, so just to review very quickly, in the science passages, you're going to be presented with graphs and charts and tables. Take a few seconds to orient yourself, understand what the axes are showing you, any general trends. If you establish any relationships, such as volume always increases when the temperature increases in this specific experiment, then write down those arrows as a quick note. That'll help guide you through questions about relationships. Be prepared if you don't find the info in the graph or chart, just to glimpse into the paragraph and look for keywords there. And last but not least, be aware of hypothetical questions that introduce new information that may not be immediately obvious within the passage. You may have to think about going and adding a data point within the information you have, or like we just did, extend the pattern outside. That's called extrapolation, pulling the pattern beyond the graph or chart to make an assumption or inference about where that data would be. Okay, I hope that was a helpful introduction and insight into the ACT science passages and what to look for and what's important. Just a reminder, we'll be here doing Test Prep Time Plus. So that's the half-hour class where you get a little more in-depth on topics. We'll be doing one today at 1 o'clock on historical passages for the reading, And then tomorrow we're going to look at adding and deleting sentences on English. We also have full-length classes. There's actually an ACT class starting on Sunday afternoon. This is a full class that goes for about 18 hours. It'll meet every Sunday online, and you'll cover every major concept or strategy on the ACT. We also do one-on-one individual private tutoring for these exams, SAT and ACT, as well as academic tutoring. If you need help in a certain subject in school or preparing for upcoming AP exams, just reach out. Happy to help you and set up some online tutoring. You can give us a call if you have any questions about anything you saw covered here or general questions about test prep, and you can find a lot of information on our blog as well on our website. Thanks for joining us today. We'll be back tomorrow at 11 a.m. for another free 15-minute class, Test Prep Time Live. My colleague Kevin Dennis will be teaching tomorrow. Join us again at 11. Hope everyone has a good day and good luck on the exams.